Good morning, everyone. Thank you for having me here today. Sorry. Okay. So transient-state relaxometry methods can jointly estimate T1 and T2, and given the short scan time, they can really facilitate the deployment to the clinical environment. Moreover, these methods show high intra-vendor repeatability and reproducibility. The problem for multicentric study is that at the moment there is no TSR method that is available for a platform, and the different implementation have different sampling trajectory, flip angle schedule, and image reconstruction approach. At the moment, we have MRF implemented on Siemens scanners, MRStat on Philips, and QTI implemented on GE Healthcare. And this variability can really hamper multi-center studies. So the aim of this work was to assess TSR repeatability and reproducibility on 3T scanners from 3 different vendors in a phantom experiment in a traveling brain study. So in this work, we had like 4 sites involved. So 2 scanners were from GE, 1 from Siemens, 1 from Philips. Here you can see the different type of sequence that were implemented at each site. And we tried to keep the spatial resolution, the in-plane spatial resolution and the scan duration as similar as possible. For the first step, we acquired a phantom that consisted of 5 vials from the Eurospin of 5 objects. And we scanned the TSR method twice at each site and acquired a gold standard protocol for the evaluation of quantification accuracy. Then for the traveling brain, study, we acquired the images of 5 healthy volunteers. Again, repeating the TSR method twice, and then acquiring a T1 weighted image for anatomical reference. For the phantom, we automatically segmented the vials and estimated the bias with a Bland-Altman analysis. While for the traveling brain, we normalized all the images to a study-specific template and then applied a 3 mm Gaussian smoothing. And then at this point, we estimated voxel-wise coefficient of variation to provide a measure of variability, and then via GLM we estimated the bias. And in this case, test-retest subject and site were used as covariates. These are the results of the phantom experiment. We found excellent agreement with the gold standard, except for very long T2, so mimicking the CSF. And then we found excellent intrasite repeatability and good intersite reproducibility. These are the results of the in vivo maps. So the same subject acquired the 4 scanners, and we got T1 and T2 values that are compatible with literature reports for all methods. Then for the intra-scanner repeatability, that was excellent, while the inter-scanner reproducibility, it really depended on the site pair. Like for example, you can notice here that we have lower reproducibility, but maybe I can lower reproducibility when comparing 3D methods like QTI implemented on GE with 2D methods like Philips, MRStat, and MRF implemented on Philips and Siemens. In any case, the coefficient of variation remained lower than 12% for T1 and then 20% for T2 in solid tissues. For the GLM, we found that the bias associated with T1 was around 100 milliseconds, and it was uniform across the brain. And we hypothesized that this may be due to empty effect, while the bias on T2 was non-uniform, and it showed a B1-like pattern, and it was around 10 milliseconds. So overall, we can say that TSR implemented using vendor-specific sequence show excellent repeatability and overall good intrascan reproducibility, and it allows multicentric studies. But if we want to detect pathological variation that are lower than 100 milliseconds for T1 and 10 milliseconds for T2, the implementation of vendor-agnostic protocol is warranted to reduce MT and B1 effect and boost intersite reproducibility. Thank you all.